Okay, welcome back to 8.4 day day 3. That's what we're at. Okay. Again, we're going to be talking about how to do factoring, but today's goal is we are going to be looking at it in a slightly different way than yesterday's lesson. Yesterday we looked at kind of a guess and check. So for example, again, the goal is can I turn a trinomial like this into two binomials multiplied together? The message today is still the same. I'm trying to reverse distribution. I want to try to make sure that I have it so that I can think of it in terms of if I were to take this two binomials and multiply them back out, I should come out to the other part. Okay? Real quick, just a fast reminder, what does factored form mean? So I can actually do a factored form in terms of numbers. Like factored form here, I can split them up like 15 times 10. That's factored form. And I can even take it further. So 3 times 5 and 2 times 5. We've done something like this before. That's what it means by factored form. This is our list of prime factors. Okay? Same idea here. I'm trying to get into factors. Factors being things that are multiplied together. So what we did yesterday was, well, I know it needs to be x and x here. I know that because it's a positive and a positive, I need to have two positives. And then I have a 10 here and a 7 in the middle. So it's got to multiply to 10, add to 7. So if I get that pattern, it's going to be 5 and 2. Okay? Today for our different method, quicker. Hey, you know what? I'm going to skip this one because we've talked about GCF. Never mind, let's skip it. Let's talk about it real quick. So again, when I look at my four terms, I'm looking at, here we got a little bit extra challenge from yesterday. I have x's and y's to work with. So first thing I'm going to focus on is the numbers. I've got 15, 45, 90, and 60. Okay, so you want to think about what number can I take out of everything. Luckily, 15 is actually the number I can take out. Okay, then I'm going to look at my x's, and I'm going to look at all of my exponents. Well, I have x squared, x to the fourth, x cubed, and x squared. So the largest x that I can take out is an x squared. And then I finally finish with my y's. I got y to the seventh, y to the third, y to the fourth, and y. Well, when I look at that, y is the biggest one I can take out because that's my smallest exponent. Okay, that's an easy way to figure out for my GCF, the x's or y's that can come out. It's always the smallest exponent, as long as it's in every term. So now I just need to reverse my distribution. I got to think of 15x squared y times what gives me 15x squared y to the 7th. So that's going to give me just y to the 6th. Okay, 15 times what gives me 45 is going to be a negative 3. Take an x squared out, I'm going to have x squared here, y squared. Okay, take a 15 out of 90, and that should be a 6. X squared out of x cubed is an x left over. Y out of y to the fourth is y cubed left over. And then my last term is going to be 4, or negative 4, I should say. X squared is taken out, and y is taken out, so I'll just leave that as a negative 4. So that's another, just a little extension from yesterday when we do a GCF that's a little more complicated. Okay, our new method for factoring our trinomials today. What we're going to be doing is what's called the AC method. The reason we're going to do this is, if you think about when we do distribution, we multiply two binomials together, we ended up with 4 terms that get multiplied together to get to a 3, or that add the two middle terms together. So for a quick example here, x plus 2 times x plus 3, and I get x squared plus 2x plus 3x plus 6, and the idea is that I get 4 terms, but then the two middle terms come together. So that's how I turn it into a trinomial. Okay? So the idea here is, can I take my 3 terms and make it into 4 terms? That's the goal here. Can I turn it into 4 terms so that I can reverse this distribution idea? So when I call it a times c, we're going to take here, it's 1 times 30. So 1 times 30 gives me 30. Okay? It doesn't make any difference now, but think of it it's going to be for the future, make it a little bit easier. So I want to multiply by to 30, but add to 17. So I try to think of the two numbers that do that. I get 15 and 2. So the goal here is, can I turn this into 2 terms in the middle that still add up to 17x? And this is still an accurate description here. x squared plus 15x plus 2x plus 30 is the same thing as my starting point. Well, now let's look at these as two sets here. This was the result. Again, we're thinking of reverse the distribution here. Out of x squared and 15x, they have an x in common. What's left is x plus 15. Out of 2x and 30, I have a 2 in common. So when we did our distribution 2 lessons ago, we know that x is going to be multiplied out here and 2 is going to be multiplied out here when we did our distribution. So if I reverse the order, x plus 15s match up. So I'm going to have x plus 15, x plus 2 here. And yes, you could have gotten that through the guess and check a lot quicker, but I'm going through this new process here. I want you to see this because it's going to apply when it's a little bit harder for my factoring. Okay, so here's this one. Factor this trinomial. First step is, we haven't talked about this style yet, but let's take a look. Can I take out a greatest common factor to start? Well, when I look at these, my greatest common factor is 3x. I can take that out of everything. So I'm left with an x squared plus a 3x minus 40. Now I'm going to look at, well, how do I factor this part? Just for shortcut for today, I'm just going to go ahead and do our guess and check idea. So I know it's got to be x and x. I know it's a negative 40 and a positive in the middle, so I need a plus minus, and my positive is going to be bigger. So what multiplies to a negative 40 adds to 3? So I think about that. Let's see here. We've got 8 and 5. So it's going to be a positive 8 and a negative 5. So therefore, we look at this. This is my complete factorization. And keep the 3x as a part of it, because that was a greatest common factor. Okay? Here's where we get some trickiness. We don't have a greatest common factor. It's not there. So here's where I'm going to do the a times c method. So I'm going to take 3 times 10 gives me 30. So now the goal is what multiplies to 30 but adds to 11. So if I think about that one a little bit, that's going to be, where am I at? Multiplies to 30, adds to 11. So I'm having a little bit of trouble with this, so I'm going to list out everything that multiplies to 30. So I got 1 times 30, 2 times 15, 3 times 10, 4 does not, 5 times 6. Wow. 5 times 6, there it is, 5 and 6. Okay, so like we just said, we're going to take 11x and split that up. So 3x squared plus 5x plus 6x plus 10 is going to give me that number there. So one thing that's a little bit different that I'm going to try out is a few days ago we talked about multiplying with a box. So today I'm going to actually factor with a box too. I know my goal is to have something like this, 2 binomials. Okay? So here's what I'm going to do. If I have 4 terms, I can fill out my 4 square boxes. But in this case, because I'm factoring, I'm going to fill out the insides. 3x squared, 5x, 6x, and 10. So now when I look through here, all I need to do is I need to look in one direction. 3x squared and 5x, what is a greatest common factor for both of those? Just an x. After this, I'm just going to think through logically and try to multiply things out. For example, x times something gives me 3x squared. Well, that's a 3x. X times something gives me a 5x, that's going to be a 5. 3x times something gives me 6x, that's going to be a 2. And just to double check, 2 times 5, that is 10. So actually, I've got 3x plus 5, x plus 2. This is a different method of doing it, but these are factor by grouping, just like I did on one of the other examples. Okay? The goal of factor by grouping is, can we split the middle term up, turn it into 4 terms, and then go through and factor it out. So again, it doesn't matter how you want to do it. We're just going to do it in either a box method or in a or in 2 sets of parentheses. Okay? So again, one more time, I'm going to do 20 times 7 is 140. So I'm going to need 2 numbers that multiply, negative 7, negative 140. So I need to multiply to a negative 140, add to a positive 23 in the middle. When I do that, I get 20x squared is going to be a positive 28x negative 5x and negative 7. Those are my two numbers that do that, 28 and negative 5. So this is my grouping idea. I'm going to start with this. What can I take out of 20x squared and a 28x? I can take a 4 and an x out. I'm left with 5x plus 7. Out of a negative 5x and a negative 7, they're both negatives, so I'm actually going to take out a negative 1. I do that, I get 5x and a positive 7. I'm reversing the distributive property here. Well, since these two match up, that is going to be one of my factors, 5x plus 7. My other factor is going to be made up of 4x and a negative 1. And there's my final factor form. I don't care if you want to do it with these parentheses or with the box method like this one right here. Do it what makes sense. So my next two examples, this is another factoring thing. Then we'll get to a 4-term factoring. So this is, we can still treat it like we did yesterday. We can make it a 0x in the middle. But this has a special pattern. It is called the difference of two squares. And what that means is if I have my binomial look like this, where it's in the format of a squared minus b squared, it always factors into this style, a minus b, or a plus b, a minus b. So these two are perfect squares. And so if I look at a squared being x squared and b squared being 49, okay, that would make a x and b 7 if I take the square root of both sides. So therefore, my factoring here is, not a, x plus 7, x minus 7. So this is, what's nice about this factoring method is it's a shortcut if you can recognize it. So for example, 36x squared negative 81. A squared, if I say that a squared equals 36x squared and b squared equals 81, I want to identify, are these perfect squares? Yes, they are. Because if I square root this is going to be a 6x, this is going to be a 9. So therefore, this is going to factor into 6x plus 9, 6x minus 9. And technically, I can actually still take out a 3 out of everything, but I'm going to skip that for now. Okay? Last part is 4 terms. And again, this is going to work just like we've done for the other ones. Here I'm starting with 4 terms, and I'm doing something with the x cubed here. So I'm going to focus on 2 sets at a time. So just like before, what can I take out of x cubed and 4x squared? All I can take out is an x. So I'm left with x squared minus 4x here. No, sorry. Let's fix that part. My bad. Take out an x squared, I'm left with an x minus 4. Out of 3x and 12, I can take out a positive 3, and I'm left with an x minus 4. Since x minus 4s match up, I'm going to rewrite it as x minus 4, and then the remainder here is x squared plus 3. And there it is. There's my final factored polynomial for that one. And one last example, because again, like I said, as long as I have 4 terms, that fills up a nice 4x4 or 2x2 square. Okay, so I'm going to take all of these terms and put them on the inside of the squares, 6x cubed, 18x squared, negative 7x, negative 21. If I look in this direction, what can I take out of 6x cubed and 18x squared? I can take out a 6x squared. That was my common factor if I look horizontally at the first row. After that, it's just a matter of common sense, and I got to go through here and say, well, 6x squared times something gives me 6x cubed. It's got to be an x here. 6x times something gives me 18x squared. It's got to be a 3. Come down here and look at this row here. X times negative 7 gives me negative 7x. And just to double check, negative 7 times 3 is indeed negative 21. So my two factors are right here. X plus 3, 6x squared minus 7. So that concludes all of our factoring methods that we talked about. So as a recap, we can look at factoring as greatest common factor. We start with that. Is there a number and or variable that I can take out of the polynomial? After I do that, if I'm left with a trinomial, I'm looking at how do I factor that. We can do guess and check like yesterday. You can do this method here where we split that middle term up, turn 3 terms into 4 terms. The pattern that we look for is still the same. Multiply it to the final term, add to the middle term. But we split up that middle term, we got 4 terms, and we're reversing the distribution property. And we can also use the box method for that as well. And the last thing is, how do we factor with 4 terms? We can look at them as two groups of 2, or turn them into a box method here and try to take out there to find our greatest common factors. And also our last thing, which was looking at difference of 2 squares. A squared minus b squared is going to be the same as a plus b, a minus b. So that concludes our 8.4 and all of our factoring for this unit.